let's put together a strategy that we can follow to draw isomers of hydrocarbons. For example, C7H16. The first thing you want to do is determine if this is completely saturated, meaning there are no double bonds or cycles. And the way to do that is to use a formula, if you wish, 2n plus 2, where n is the number of carbons, right? So the number of carbons here is 7. 2 times 7 plus 2 equals 16. And since that number is 16, that means this is completely saturated. This helps us. If this number was, for example, 12, what we would do is we would subtract the number 12. We would get 4, divide that by 2. That means we have 2 degrees of unsaturation. That means we have either 2 double bonds, or we have a triple bond, or we have a cycle and a double bond, any combination. So the reason for that is that if you have a completely saturated hydrocarbon, right? So every carbon needs 8 electrons. So every carbon needs 8 electrons or 4 lines, right? So in the example below, I have C3. So every carbon here has 2, let's call them core hydrogens. And you can keep that going and going. And as long as we keep going, every carbon just needs to have 2. But at some point, you're going to have 2 ends, and you're going to have to cap them off. So we need to add a hydrogen at each end. This is where that plus 2 comes from, right? This is the number of hydrogens, 2 for each carbon, and then that plus 2 comes from capping it off at each end. So this works really well. And then for every 2 hydrogens you take away, right? That's why I divided the number of missing hydrogens by 2, right? If we took this away here, we didn't have them, we would take also all of the hydrogens away. I mean, the electrons, you would have to make a double bond right here. Or you could actually connect it in a triangle like this. That would also work. Okay. So whichever way you do this, you can memorize the formula, but that's what I would do. So now that we know that we have a saturated hydrocarbon, you start out with making a long chain. And I would completely ignore the fact that each carbon has a tetrahedron and that should zigzag up and down and the hydrogens come towards you. Just draw a long chain, just straight line, 7 in a row. So 5, 6, and 7, and just put your 8 lines in and cap off each of those lines with your hydrogen. This should be C7H16, and we can name these as well. This would be heptane, 7 in a row, no groups attached, no chlorines, no double bonds, so this is just called heptane. Right? Let me make sure I did that right. 1, 2, 3, 4, 5, 6, 7. Yes, I did that right. Then that's number 1. Your strategy is to follow this pattern. So you then chop off one of them. So you have 6 left. 1, 2, 3, 4, 5, 6. You draw in your lines. Okay. And you now have one group that you have, in fact, either this one, it doesn't matter, one of the CH3 groups is chopped off. It goes back on this here, right? So you want to recognize that this position here, where I'm drawing one, all 3 of those are equivalent. So, and because those are tetrahedron, and because there's symmetry here, that means all of those are equivalent too. So you cannot put this CH3 group back onto the number 1 position, because that would just make the same isomer again. So that's your strategy, don't put it back. So you can on the second, right? So we have the second carbon here, but those 2 positions are also equivalent. And because this is symmetrical towards the other end, these are also equivalent, right? So you have only one other position here where you can put that methyl group, okay? And then there's a third position where you can put it, okay? So we're going to eliminate that position here, and so then this should have 2 isomers. So we have 1, 2, 3, 4, 5, 6, and I'm going to put it here. This is the number 2 position. This is one of the isomers. Okay? And I'll take my time because I have plenty of time on the exam to draw everything, all of the hydrogens. Okay? So this would be 2-methylhexane because this is the number 2 position, whether I put it here or here. The other one is on the 3 position, so that would be called 3-methylhexane. So I do this. This is my second one. This is my third one. So 1, 2, 3, 4, 5, 6. And then I'm going to put it on the number 3 position here. And now all I have to do is fill in the hydrogens. So 1, 2, 3, 4, 5, 6. Just put them all in. You know, I'm gonna skip that. But those are now 3 isomers, and now I do the same thing again, which is chop off another carbon. So now I have 5 in a row, and I have 2 carbons to spread out. Now the rule still applies that I cannot have anything on the first or the last. That will just extend the chain. And so my new positions are the second, which is also the next to last, so the 4th carbon if you wish, and the 3rd. Of course, now I have 2 carbons to add, or 2 methyl groups, and so I can put them both on the first one. So that would be one of the isomers, 2,2-dimethylpentane. I can put them both on the third one, so that would be 3,3-dimethylpentane. Now if I put them both on the 4th one, well, that's the second one. So that one would be identical to what we just drew. This is isomer 4. This is isomer 5. So those are the only 2 ways to put them on the same carbon, but then I also have several ways to do the, I can do the 2nd and the 3rd, or the 2nd and the 4th. Yes, unfortunately. So this would be my 6th isomer. So unfortunately, I can also do the 2nd and the 4th, because the minute I put a carbon on the 2nd position, the identical 2nd position becomes the 4th one. So this is clearly connected differently. And just to be clear, when you draw those on an exam, you will be required to put all of the hydrogens in. I will not give you full credit if you do what I am doing. I'm doing this to save some time. Okay, so practice drawing this a little bit. Chances are I will give you something we've done already in class or is on one of the homework sets. So I kept, so 6, okay, so this is then 7. Unfortunately, we also have, we can also put both carbons together like this, okay? That is an ethyl group now, and we couldn't do that on the 2nd carbon. If you do this on the 2nd carbon, so this is my 8th isomer, so this would be 3-ethylpentane. If I do this on the 2nd, I get the 1, 2, 3, 4, 5, 6. So I would have a hexane here, and we've already drawn all of the hexane ones. But you can, in the center here, you can have that one. And then finally, we can chop 3 hydrogens off. 1, 2, 3, and 4. So we get 4 remaining carbons in a row. Again, I'm going to eliminate the first position, and then there's only one way to put 3 carbons in the 2 center ones, which, like, this is the only way to do it. Okay, so this would be 2, 2, 3 trimethylbutane. And nobody can read that. That's okay though. And this would be my isomer number 9. All right, so just take a look at this again. Heptane, we made a long one where we chopped one off. We found 2 positions. And naming them also helps come up. And anyway, that's all I got.